Okay, question 13 of the Polynomials exam style question section. The roots of the cubic equation x cubed plus 2x squared minus 3x plus 2 equals 0 are alpha, beta, and gamma. And then it says find the value of 1 over alpha beta times beta gamma times alpha gamma. Alright, first up, just a few things we can observe. We know that the sum of all of the roots is equal to negative 2 divided by 1, so negative 2. The sum of any product of two of the roots is equal to positive negative 3 divided by 1, so that would be negative 3. And then all three of the roots multiplied together are equal to negative 2 over 1, so negative 2. Okay, so moving back to A, clearly this thing here is 1 divided by alpha squared, beta squared, gamma squared, so 1 divided by alpha, beta, gamma squared, and so that's just equal to 1 divided by negative 2 squared, so 1 divided by 4. Part B asks us to find the sum of 1 over alpha beta plus 1 over beta gamma plus 1 over alpha gamma. Now you can do this using algebra, just combine it into a single fraction and then make use of the sums that we already know. I'm going to do it using substitution because that will work as well, because we can observe that this sum here is the sum of the product of any two roots of the cubic equation equal to 0 that has 1 over alpha, 1 over beta, and 1 over gamma as the roots. So let's go ahead and find a polynomial that has 1 over alpha, 1 over beta, and 1 over gamma as its roots. Now that's actually pretty easy to do because we know alpha, beta, and gamma are the roots of this equation here. Dividing through by x cubed gives us 2 times 1 divided by x cubed, and then it's going to be minus 3 times 1 divided by x squared, and then plus 2 times 1 divided by x, and then just plus 1 equals 0. So we know alpha, beta, and gamma are solutions to this equation here. So roots alpha, beta, and gamma. And so that tells us that the polynomial p of z equals 2z cubed minus 3z squared plus 2z plus 1. And if we set that equal to 0, it has roots 1 over alpha, 1 over beta, and 1 over gamma. So nothing too complicated there, just a substitution. The substitution being z equals 1 over x, of course. Anyway, we know that the sum of any two of the roots should be equal to our c divided by a. So this is a, this is b, this is c, this is d, and we know that the sum of alpha beta is equal to c divided by a, so that's 2 divided by 2, which is equal to 1. And so that is actually the answer to part B. Must be 1. And moving on to part C, we can make the observation that all three of these terms have a common factor of 1 divided by alpha, beta, gamma. So it's equal to 1 divided by alpha, beta, gamma times 1 over alpha plus 1 over beta plus 1 over gamma. Now we know 1 over alpha, beta, gamma is equal to, well, alpha, beta, gamma is negative 2. And we can see here as well it's negative 1 divided by 2. So yeah, 1 over alpha, beta, gamma is negative 1 divided by 2. And then we have to times it by 1 over alpha plus 1 over beta plus 1 over gamma, which is the same as negative b divided by a. And since b is negative 3, this has got to be negative 3, negative b, that would be positive 3. So positive 3 divided by a, which is 2. And so we end up with negative 3 over 4 here. Okay, and then for part D it says deduce the cubic equation with those roots there, these 3 roots here. And we can see that in part A, B, and C of this question, part A gives us the product of all 3 of the roots, part B gives us the sum of the 3 roots, and part C gives us the product of any 2 of the roots multiplied together. So for part D, let's suppose our polynomial looks like this. X cubed plus b x squared plus cx plus d, and we set it equal to 0. Then we know that the sum of any of our roots are negative b divided by a, which is 1 in this case. We can choose our a because there are actually infinitely many of the polynomials equal to 0 that have these 3 particular roots, depending on what your choice of a is. So it's simplest to make a 1, of course. Alright, so negative b is equal to the sum of the 3 roots, which is 1. So that tells us that b is equal to negative 1. Now c divided by 1 is equal to the sum of any 2 of the roots multiplied together. So that's what we got here. And so that one is negative 3 divided by 4. So c equals negative 3 divided by 4. And then d is the negative d is the product of the 3 roots multiplied together. So that would mean that d is equal to negative 1 over 4. And then everything's nice and easy. We just got to put in our values. So we get x cubed minus x squared minus 3 over 4x and then minus 1 over 4 equals 0. And then if we want to make it all nice, we can times everything by 4. So 4x cubed minus 4x squared minus 3x minus 1 equals 0. And so that is our cubic equation that has the roots 1 over alpha beta, 1 over beta gamma, and 1 over alpha gamma.